So in this session, we are going to discuss about some of the problems related to the pulse Doppler radar and MTA radar. So we know what is actually an MTA radar and the pulse Doppler radar. So let me explain you about the pulse Doppler radar briefly. A pulse Doppler radar determines what? A range of a target by measuring the round or trip delay of transmitted RF pulse signal returned by the target by receiving an echo signal. So this echo signal will be what? Compared with the actual transmitted RF pulse and determining the round trip delay as well as some of the other parameters, that is nothing but a Doppler, shift, carrier frequency and all. So there are some continuous wave radar which is also called as a pulse Doppler radar. So by using this one, we can calculate, like here, we are going to determine some of the problems related to the pulse Doppler radar. So first problem, a 3.5 centimeter pulse radar, a pulse Doppler radar has a pulse repetitive frequency of 4000 pps. That is, we have to calculate R unambitious, the frequency, that is FD max and V max. Here, for the calculation, we have to first write it down, the given data. The value of a lambda is 3.5 centimeter and pulse repetitive frequency is 4000 pps. So for that one, R unambitious can be calculated. As we know, the relation between the R unambitious range, or we can say the maximum unambitious range, that is given by the C divided by 2 PRF, that is pulse repetitive frequency. So where C is the velocity of light in terms of meter per second. Now we are going to represent that one into 3 into 10 to the power of 8 divided by 2 into 4000, that is PRF value. So ultimately we will get the value of our unambitious range, our maximum unambitious range by 37.5. It is in terms of kilometers. Okay, it is not mentioned over here, but it is in terms of kilometers because the velocity will be mentioned in terms of meter per second, and always all the range calculation will be in terms of meters. So it is here in terms of kilometers, you will get it. Next, the FD max, we are going to calculate the frequency, the Doppler frequency, our highest Doppler shift of a frequency, that is equivalent to PRF divided by 2, pulse repetitive frequency divided by 2. So pulse repetitive frequency value is what? How much? 4000. So divided by 2, we will get as 2 kilohertz. The maximum velocity, that is V max calculation, is given by PRF into lambda by 4. So that is given by 4000 into lambda value 3.25 into 10 to the power of minus 2 by 4. So overall, this calculation, it is in terms of meter per second because it is a velocity factor. So the velocity will be calculated 32.5 meter per second. Second problem. An automobile vehicle moving at a speed of 54 km per hour, producing a Doppler shift of 400 Hz in a radial direction. Determine the frequency of transmitted wave. So for this, the solution, we have to write it down what are all the given data. The given data are the velocity, VR in terms of kilometer per hour. So FD value or frequency, the Doppler frequency value is 400 Hz, and if not, we have to calculate operating frequency or transmitted frequency value. So before proceeding into the next, we have to mention, or we have to convert this 54 kmph into meter per second. How do you convert? See here, 54 in terms of kilometer. If I wanted to write it in terms of a meter, it will be multiplied by 1000. Then I wanted to remove that hour. So in terms of a second, if I mention, hour will be mentioned in terms of second, in the sense it is 3600 seconds. So 54 into 1000 divided by what? 3600 will get in terms of meter per second. Overall value of this one will leads in terms of meter per second. So that will be converted in terms of meter per second by 15 meter per second. Now, operated or transmitted frequency f not equal to 3 into fd by 2 into Vr. So 3 into 10 to the power of 8, it is a velocity in terms of meter per second into 400, that is Doppler frequency, and divided by 2 into Vr. Vr is meter per second value, it is 15. Overall, after calculating this one, we can get it f naught value by 4 gigahertz. So this is about determining the transmitted frequency or the frequency of a transmitted microwave. Next. Third one, an MTA radar operates at pulse repetitive frequency of 1.5 kilohertz if the first blind speed of a target is found to be 60 meter per second. Then determine the frequency of a transmitted microwave signal. So here we have to calculate what the frequency of a transmitted. Once again, we have to determine the value of a f, transmitted frequency. So ultimately, the value of a f is in terms of what? C by lambda. So that value only we have to calculate here. But before calculating this one, we have to know what actually the value of a lambda. So the lambda value has to be calculated first, because the value of a actual speed or a velocity is given, and also the value of fp, we can also call it as a fp value, is given. It is around 1.5 kilohertz. Okay, solution. The first one, like with the nth blind speed, we have to write it down the velocity factor of Vn equal to n into lambda fp by 2. So for the first blind speed, we have to substitute the value of n by 1. So Vn equal to lambda into fp by 2, because value of n is equivalent to 1. Now it is equivalent to, because it's a value of a V1, or the first blind speed is given by what? The first blind speed is 60 meter per second. So the value of V1 is 60 meter per second. Now from this we have to calculate what? Lambda. Okay, because fp also it is given. How lambda is calculated? 2 into 60 by fp. So fp, it is 1.5 into 10 to the power of 3, and after calculating this one, we are getting 0.0 meter, or in terms of a centimeter, it is 8 centimeter. Now the frequency of a transmitted microwave signal, as we know the relation between the frequency and the wavelength. So f equal to c by lambda, where c is the velocity of light in terms of 3 into 10 to the power of 8 divided by the value of the lambda, 8 centimeter. We will be getting the frequency or transmitted frequency by 3.75 gigahertz. So in this way, we have to calculate some of the problems related to MTI and pulse Doppler radar.